Good day, everyone. Welcome to today's webinar. We are going to talk about the smart solution for Rebar Shops, boost productivity and reduce waste in one platform. I am your host. My name is Asim Leri. And just to give you a bit about me, I'm the product manager of Advanced Workshop Rebar for Graitec. In terms of my background, I have about 14 years experience within the automation, construction and software industry. I have developed and am a patent of an offshore product. I have driven and guided new softwares in the construction BIM market. I myself am a BIM consultant and I've project managed multi-million pound projects. So that's my background, and so today I will give you a brief introduction of the rebar industry and what solutions we provide as Graitec, which is the Advanced Workshop Rebar. So just to give you a larger picture where the Advanced Workshop is best suited within the BIM cycle and what other products Graitec provides in terms of its IP. So when we look into this BIM cycle, within the fabrication part, we have the rebar, steel, and precast that conducts into the software. Then we have the construction of 4D and 5D, which is very much the time and cost simulation. We have the construction logistics, the logistic part, and as well as the traceability. So Advanced Workshop covers all of these factors through the traceability, through the fabrication part in terms of rebar and precast. Construction 4D, so in terms of time and cost simulations to provide cost of the product in terms of time, when to produce and the structure, and the construction logistics of when to deliver, how it's delivered, and so on. On the other part, other Graitec IPs cover on the analysis, detail design, and conceptual design, which is very much the simulation part. So where you design and perform analysis for it to be produced. So which comes into the advanced workshop part. So bit about the rebar industry and its requirements. I've placed in two sides of the coin here. So one is the client project construction side, the requirements from their side, and then what is the expectation from the rebar fabrication or fabricator part. So within the client project construction side, they are looking into, and what they request is mostly in the rebar need to define on a project level. This is in terms of length. They request in series of partial deliveries, call-offs. So rather than having it all lump sum of delivered to them on site, they would rather have it partially. So that's more of a logistic problem on that side, and as well as the project base. As time goes, they require more or less requirements. And then last but least, they would like to look into the structural safety and the quality of regulations. And when we look into the fabricating part of the coin, they are requiring and they want to move on to the delivery only specific parts of the whole, no more no less. Now the rebar fabricators are not conducting with one customer, they're working with multiple and severe multiple customers, and they need to be producing their products on what we call rebar simultaneously for profitability. And that includes the optimization part, where you wish to optimize all the production in such a manner so you are more efficient and as well as cost saving, and reducing the scrap as well. So that's one part of it. And then the last but least, you need to handle commercial changes in terms of the cost, in terms of quotations, and all the ERP sections that is required. Now, in terms of the journey of rebar, these are the typical needs of requirements for the rebar to go through with for it to be on site. So on one section, you've got the customer inquiry where it needs the rebar info, delivery constraints, and CRM. You need to have a supply chain. You need to have stock. You need to have procurements and accessories, sundries for it to be producing rebars to the customer inquiry. And once you have both of them, you can go into production, which is the machine, capacity utilization, workforce operations. And once the production is done, you go into logistics. So you need to deliver location and what type of fleet or trucks that is best suited for that delivery. Um, you also need to look into the quality because that's what the site manager's expectation is the traceability to provide them information of the quality, provide standards, provide workflows in that means. And the last but least is the accounting, which is the RP section where you are mostly working on the payments, proof of delivery, and accounts, and following on through how the process works. So these are the typical needs of for a rebar on site, and they need to work on this on a regular basis. What I want to do is I want to concentrate on the customer inquiry part with the rebar info because it's quite critical to understand this. Because if you know this, then you will understand the softwares that are and the solutions that are provided for the rebar industry. So typically for a rebar data, you have the simulation part where you have the engineering intent and the design details, so whether that's going to be in 2D and nowadays is excelling in the form of 3D rebar modeling. And once you have that simulation part done and the design it's produced, you need to bring that into the bar bending schedules, whether and that needs to be defined within the bar marks. So the bar marks are the smallest unit of a complete rebar job activity. So any rebar projects can communicate using many bar marks. So it's quite critical in terms of the bar marks. So just to understand what bar marks are, the smallest unit of activity in the rebar industry. So you have the material grade, so materials properties to satisfy the structural performance requirements, and then you have the bar diameter and a number of bars required. So these are the chosen satisfied for the rebar densities, rebar ratio, defined in engineering design intent, and then you have the geometry, which is the structural analysis. Results indicate where rebar needs to be placed, um, fine-tuned, detailed with constructability constraints. So many of these bar marks make up a structural element, like a beam or a pile cage or and etc. And many elements make up phases in projects. So you may have a level in the building that needs multiple elements. Some elements can be repetitive, and many phases to complete a complete project. So that's the concept of how things work. So if I give you the solution and what we provide in terms of what I've described earlier on, we in Graitec have a software called Advanced Workshop. Advanced Workshop Rebar is an advantage in the day-to-day activities. So it covers mostly what I've shown you in the background of the typical needs of rebar industry. What I wanted to do is describe the basics. So the first one is the means of receiving the rebar info into the software. And then you have keeping track of it all throughout the sales and production cycle. And then we ensure correct delivery, quality, time, and quantity. And how do we do that? We go into the rebar requirements of a job that are defined as bar marks, as I mentioned to you what bar marks are. They are listed in a bar bending schedule, what we call BBS in short term. Um, that moves into the keeping track, where many customers, each with many projects, requesting bar marks from their own pools with time and quality and constraint. And then once it comes to the ensuring delivery, so we uh, do deliveries to meet clients' requests, fleet constraints with sufficient records for the business needs. And we do what we do with regards to this is to divide the jobs into smaller units of work when it comes to receiving rebars. Um, we then process the numerous small units of work, and then we deliver various combinations of work units when it comes to delivering the quality in time and quantity. So when we look into the hierarchy of our software, you have the customer, which is the company group hierarchy possible, and then that customer has multiple jobs, and that's projects. So you have multiple job sites, which are zones, segments defined with physical or commercial segments. These job sites will have bar bending schedules, drawings, and they could be grouping it to manage projects in smaller parts. And these bar bending schedules will have elements. Again, as I mentioned to you before, bar marks is a smaller unit, so then you have multiple bar marks to construct a element, and then multiple elements can be defined in that manner. So that's how you stage. So you have the BBS, you have the elements, which is the structural elements, and then you have the bar marks, which is the individual bar marks. Materials, grades, bar diameter, geometry, quantity, identical bars within the element. So once you have all of this input in terms of the first stage of the structural data entry, you wish to go into production. So in terms of the data structure of operation, you have production sequence. So once you have the bar marks, you have the elements, you can send that into as a production sequence. This will then, the software will do a production run and perform optimization, machine assignments, constraints. Many call-offs can be combined into one production. Um, that will then produce production tags. So a production tag is a grouping of bars marks, can be combinations of many bars marks, or a single bar mark can be split into many tags, which then gives you the delivery preparation, which is the packing list. So once it's produced, you have the delivery preparation, so everything is packed. Then you create a delivery note for it to be ready to be delivered on and placed loaded on the truck and unloaded on site. Once it's unloaded on site, you can then produce an invoice for the client to provide you the price, the cost of it. So you can issue the invoice. So that's the whole sequence. So if I show you this in a workflow plan, you have the customer, you have the job site, you have the drawing elements, bar marks, and production planning. You also want to think about how do I bring in my resources to create these elements, the bar marks, and production planning. So you need to have stock and procurements, materials in stocks, and then produce a call off for the elements that will allow you to produce a call off for the elements. So the software needs to know how much material you have on stock for it to proceed in terms of call off. So you have the production planning, where once you have it assigned into a production sequence, you want to go into having a touch box, which is what the software, what we as Graitec provide. You can use those touch box to scan, start production, end production, and communicate back to the software in terms of the timeline and the cost and so on. You then produce a delivery note, as I mentioned to you before. So if we look into the system that we're function of this whole software, it is an MRP, MES, and ERP system. So where MES is situated is where the production bar marks and elements, the touch box is. Then you have the MRP, which is where the designing, the detailing part, the stock, the call-offs, and etc. And then you have the whole functionality of ERP, where you are storing database in terms of customer, cost, the job sites, and so on. So the software provides a combination of an ERP functions, MRP functions, and MES functions. So just to give you a brief introduction of what happens within the production plan. So production planning in detail. So delivery requirements of customers suggest that production date or production sequence call-offs, as we call it. Many call-offs concede on a day can be grouped into production runs. So as you can see in the plan over here, you have the production planning and production runs, which can be optimized. You can use a bar mark to scan this on the touch box, and it can go into cuttings, waste. If it's a cutoff, you can scan it and bring it back into stock management. You have the same concept for bending. You have the same concept for assembly. So you can scan within the touch box so it can communicate back to the software. You have the same concept of stock lengths, operations, delivery preparations, delivery note, delivery, and invoice comes into right to the end of the part. So this is a nice, good way to see how the details are. What I've shown you so far is very much an MVP, and the software does more, obviously. What we cover as a typical MVP within an advanced workshop is I've divided it into three factors, which is the sales, procurement, and stock and production operation management. So within the sales, you have customers, job sites, customer orders, prospecting, uh, um, and then the procurement and the stock, you have the items, item stocks, supplier orders, BBS and drawings, ordering of full stocks, receptions, traceability docs, and then the production, obviously, manufacturing production planning, zero tags, overall production planning, planning of production, and as I mentioned to you before, touchbox. So this is very much the MVP, and I've given you a good example of what our software does um, for the rebar industry. Um, what I wanted to do was show you what we have instilled in the new features upcoming for our softwares, which is quite exciting to see in terms of how we are developing our software to the market's needs. So first of all, what we did was we improved the project UI tab. So now, before we only had modules, but now we have this new tab called Project UI Improvement, where let me show you. Um, you have the ability to create a tab. You have the ability to add a customer in the list, as I've shown you over here. I'll select one of the customer, and within this customer, you'll see a list of job sites, a list of BBS, call-offs, and delivery notes. And you have the ability to select and create new job sites, which will open on the main screen all the information required. So for this example, I will create a demo. I can put as a job site open. Yes, I will say yes, and say job site open. Okay, and that's very much it. So I've created a new job site called demo, and you can see as over here, and I can create multiple other things. So create new call-offs, you create new BBS and etc. So if you have BBS, you can create new elements, and it will list out all these elements. And once you have the elements, you can send that to sequence for call-offs for production. Once this production is done, you can create the delivery node. It gives you the whole tree line of information, and you can simply double select or right click and open what you want to see, what you want to actually investigate, and so on. So it's quick and easy and fast way to look into this. So this is a new improvement that we brought in. The other new feature what we brought in was the prefab detailing, which is, in French we call it MAO. With regards to this, we've completely changed the whole UI and the structure of this. So just to give you an example, we have a on the left side we've got the favorite list of bar marks. We can drag and drop and simply place in the dimensions of the bar from the main bar that we require, diameter and add. So we have on one side the main bar, and on the other side we have the stirrup. So I'm just going to select bar mark 052 and place in the dimensions, so 600 by 300. And I'll just place in a couple of the other missing dimensions. And that's essentially my stirrup. So I have the main bar and I have the stirrup. Now I can place the positions of my mains into stirrups. So this is quite easy. So I can place in 3, and the software will identify exactly where these are placed. You can change the distributions if you like. You can place it in or out. You can follow it as an axle, so it sticks to that. And this is going to show me the positions of where the mains are going to be placed within the stirrup. And now I can place the stirrup into the distribution, so I can distribute the stirrups along the mains. Again, there's many ways to do this. I'm just putting in a formula of x times 250 to allow the software to count how many, so that's 8. I can specify whether it needs to be in equal left and right, press OK, and that gives me an assembly of a beam. That's how easy it is to actually design. You can also see it in 3D view live. So you can see over here 4 views. I can change it into one view. So if I go into one view, here we go. And again, if you want to change anything right now, it will change live within the 3D as well. So that's detailing. Give you another example, which is power cage detailing. Again, very simple as I did before. You place in the segment, the stirrup, the circular bar mark. You place in the mains. So I place in some dimensions. I can now place that into as a segment, how many I need as an arc. So I need 6. Either I want to put it out or in, it's up to you. And follow the axle of the stirrup. So that's how it's placed, and now I can place in the distribution of these circular rebars into the mains. Again, this is in centimeters, so 20 times 10 centimeters, and I get my power gauge. So quick and easy to do. So if we move on to another one as an example, this is a spiral. So in this you don't need to place a segment, you can place the spiral bar mark into mains. And what the software will do is once you've placed in all the dimensions, the software will automatically give you a stirrup side as well. You can then place in one of the mains that needs to be placed within this stirrup. So we'll place in 2 meter, that's 200 centimeters straight bar. We can place in how many we need in terms of segments within this stirrup, and that's it. Moving on to another new feature that we have is called additional stirrups. If you want to place in more stirrups, you can drag and drop into the stirrup, and the software will recognize, well, you place in the dimension, the software will recognize the previous stirrup and ask how do you want to place it. So you will have the ability to simply select exactly where it needs to be placed in the center, in those bars, and it would adjust according to the dimensions that you placed in. So that's additional stirrup for you. We've also added assembly arrangement. So this is a macro, new macro that we've created, called them assembly arrangement. This is quite useful for the means of you're doing it very repetitively. So you don't have to create from scratch over and over again. You just have to create once, and have variable lists and allow the user simply manipulate the value of the variables. So as I said before, the same procedure, place in the mains, we'll place in a stirrup, place in some dimensions for the stirrup, um, and then I will place in the segments where these mains needs to be placed within the stirrup. So I place in 4 in those directions to create a beam, and I'll create some distributions. So I'll create in 25 by x 10, 25, press OK, and I have essentially a beam, and what I can do is simply use this to create variables. So I can go into this variable list macro, select the mode dimension, and simply change the dimensions into entities or variables. So I can place that as a length and describe this to be as a length, and I can do this for many means. So I can go into the stirrup side, press at base, and then select base on that side, and go into the height side over here, and I'll call this H, and I feel that the other one is the same, so I'll call that as an H as well, and this will then give me the height, like so. I can also, what I can do is I can go into the distribution, and call that as an entity as well. So I'll call that distribution. So distib, um, and I can simply create a formulated value for the amount I need. I'll call that as an X. I'll create a title where I can group um, these into one situation, because you may have multiple variables. So let's call this mains dimensions, and simply place that into grouping into mains dimensions. So we'll place that there, place that into this main, and there. Okay, so I've got the mains. Everyone is situated into one folder, and I'm just going to create a next variable, and I will call that as number of bars. Okay, and again I've created a free fall variable list here, and instead of I will call that as number of bars, so that value will automatically come into this factor, and I'll times it by x. The distance will calculate itself from the length. Okay, so I've got all of this. I can go back into the mode dimension, and now I can test this to see if it works. So just simply press compute, and let's see in the 3D view how it looks like. So again, as I mentioned to you before, you can do the performance live while watching the 3D view. So let's change the value of the base, and we'll change that to 80 centimeters. Compute, and there we go, and that changes accordingly. If I want to change the number of bars, so let's change the length. That's 250. Okay, that works. Okay, so So as you can see, it's all working fine. Everything has been tested. So I'll increase the number of bars, compute, and I should get more bars there. So let's increase the length to 300 and height to be 50. Okay, and that should be good. So you can see how this works. It's quite easy in terms of the first. You're designing it first. You're adding in your variable list. So you're creating your own macro. So once you're ready, you can press the save, and that's it. So now a user can use this on a multiple basis. So when you wanted to create a new bar, you can simply select a new element, and within this new element, you can name the element. Let's call it simple beam. And here you will have the list of macros that you have created and saved. So I have the beam. So I just wanted to make sure that it is called beam. So if you want to make sure it is called beam, um, I believe you can. You can go into, you can have the list, you can call it a beam, or you can go into the list down here and you'll see the list over here. Okay, so press valid, and here we go. So it's already designed. All you have to do now is simply adjust the value, and if you wanted to add more bars, you can do so. And that's your mean. So you don't have to start from scratch. This is going to speed up the process and bring in more cost-effective efficiency. Okay, so that's assembly arrangement. Um, and what we also have is the customizable view. So we allow the user to simply move around your views, what you see right now, to any means. So you can drag and clip on to many directions. So you can select your favorites. You can move that into the other end or to the center. You can clip it onto your left, or you can simply create two parts of it. You can bring it down. So I'm just going to adjust that. So there we go. So you can hide that. Um, so and we've created two tabs. I'm just going to bring the tab back into coordinates. So you can do many things on that side. Okay. So next feature that we've added is the new feature for 2025 release, um, which is the CO2 emission traceability. And here you now have the ability to calculate the CO2 emission from the production and the transportation side. So you have the production side, you have the transportation, which will allow the software to create an invoice of the total CO2 emitted. How it's done, so if we look into the production side, you have the workshop where you can input the CO2 factor of the power supply, your electrical power supply, which is provided by the means of your electrical contract. So you can input those CO2 factor. You can then also look into your specifications for your machines, how those machines are using, what are the consumptions, kilowatts per hour. You can place that into the physical working positions manual. So you can place that values within the software, and during the production, the advanced workshop will calculate the CO2 production through the record log timed hours used for the selected machines for the specific production elements. Very much so the software logs every time taken for every production, and using that production you will simply have the CO2 emission. calculated from all these factors. So that's the production side CO2 factor. And then we look into the transportation. In the transportation, you have the CO2 factor of truck delivery. So specific truck may have a specific CO2 emission. Again, that could be found in the government body documents. So you have two when it's empty and when it's fully loaded. So you'll have two factors in that means. So that needs to be inputted for each truck that you have assigned to. And then when you are creating a delivery note, you will then specify the address. And if you have a Google API, it will automatically calculate the distance traveled from your factory site to the actual site itself, or you have the ability to manually input the distance traveled. And once you have the distance traveled for that specific truck with the CO2 factor, the advanced workshop will calculate the CO2 of the transportation through distance traveled in the assigned truck. Okay. So once you have the production and the transportation CO2 accumulated, that will be shown within the invoice for your customer. So as an example over here, you will have a impact on the production, how much CO2, impact of transportation, and impact of total CO2 emission for this specific delivery or for this specific invoice of production. Okay, so that's a new feature that we brought in. Another improvement that we are pushing towards is the using our simulation fabrication and streamlining our connection to make it as a one Graitec theme. So now, knowing that we have simulations such as your advanced design, ARCHE, which design rebar assemblies, now you have the ability to in-sync that into Advanced Workshop. Quick and easy to do. So just to give you an example, if we have to create a new drawing, we can select GTCX, and what you will have is a list of designed GTCX. You can do a feasibility check to check they match to your database, so if all is green, and it should be green, to select validate, and that's very much it. So this simply brings in your list of rebars, and as well we have the ability to show it in prefab detailing. So just to give you an example, if we go into elements again, we placed an AD beam, we can go into bars, and you'll have the list of rebars for this AD beams, so you can see all the bars that has been designed and it needs to be produced. We can also select that into prefab detailing and see how it's assembled. So you'll have the ability to see the assembly, you'll see the 3D view as well of how it looks like in terms of its assembly. So I'm just going to go into one view and let's expand that. There we go. So this is AD beam that I just imported via GTCX. So quick and easy and very easy to use. So it makes your time less and more effective. That leads me to our discussion and to our webinar. So by all means, fire away with any questions, and I'm happy to answer them.